The search for deep space mysteries has been going on since the evolution of the Earth. Space scientists, philosophers, and creative brains pursue their quest for knowledge about other planets. The Indian Space Research Organization, ISRO's Chandrayaan-1, is India's first spacecraft mission beyond the Earth orbit. It aims to further expand our knowledge about the Earth's only natural satellite, the Moon.
This is a very important mission as far as ISRO is concerned. For the first time, we are trying to send a satellite to the moon and make it orbit around the moon for collecting data from the lunar surface. Well, I think we have been working hard for last 3 years to realize the hardware and various subsystems. I'm happy to say that the satellite is just ready and almost all the tests have gone through successfully so far.
Chandrayaan-1 is the country's first unmanned mission to the Moon. The mission, with a lifespan of 2 years, will help scientific investigations of our nearest celestial neighbor by systematic imaging and chemical mapping. The Moon is the nearest celestial body to Earth and lies at a distance of about 386,000 kilometers from the Earth. Though dozens of manned and unmanned spacecraft have explored the Moon, there still are several untapped mysteries of the Moon.
The manned missions, most of the landings were near the equator and around, I think, were the studies they conducted. And they haven't covered the entire Moon. It is like you see one small portion of the Earth, a small taluk in India, if you see it, you don't see the entire India. Like that, people are studying a portion of it. Limited studies were conducted other places. And what we are trying to concentrate is the entire Moon. So we will be mapping the entire Moon, both the visible side of the Moon as well as the back side of the Moon, which normally we don't see. And the poles. There are a North Pole and South Pole, just like the Earth has got 2 poles. The Moon also got 2 poles. And that's a very, very little surveyed locations. And we think there are some good observations possible at those locations. And one other thing we are looking for is whether you get water in the poles. The place where we doubt there could be water is the poles. So we will be looking specifically at the poles. And the other areas, the entire Moon will be covered for the first time with so many instruments and such detail. And nobody else has done like that till now.
The spacecraft of Chandrayaan-1 is cuboid in shape and will weigh 1,304 kilograms during launch. Once it reaches the lunar orbit, covering a distance of nearly 386,000 kilometers from the Earth, its weight will go down to 590 kilograms, as most of its propellants will be depleted during the 5.5-day journey. It has a single solar array to generate power of nearly 700 watts. Chandrayaan's energy will be gathered from the sun. The solar array with light-sensitive cells will generate 700 watts during peak period. During eclipse, it will be powered by lithium batteries.
The upcoming missions, the future planetary missions, we expect there should be international cooperation should be a place. When we go outside this world, earthly, nearly heavenly bodies, let all the people go together. Let the common wisdom of the whole humanity prevail when you go into the mission is concerned. For that, the Chandrayaan-1, we are leading a role. So unlike other missions, what we talk about, people going on their own, we are going to take the people along with us. Okay, and we are going to run a trend set for that, so that this is going to continue subsequent our missions also. So this way we feel we have our own reasons to go to the moon, and we want to take the whole humanity along with this. Common wisdom of the whole humanity prevails when we go outside the world.
There are 11 scientific instruments, popularly known as payloads, on Chandrayaan-1. They include 5 instruments entirely designed and developed in India, 3 instruments from the European Space Agency, 1 from Bulgaria, and 2 from the United States of America. The 29-kilogram Moon Impact Probe, MIP, is an Indian payload to demonstrate the technologies required for landing a probe at the desired location on the Moon. It will crash land on the lunar surface to identify future landing sites and explore the Moon from a close range.
We configured a small, a micro satellite you can call, which is a part of the main Chandrayaan, which will be detached from the Chandrayaan-1, and will go and land on the Moon. We call it as an impact. It's not a soft landing, it's an impact. It's an instrument. First of all, it will be the first Indian-made object to touch the Moon. That is the significance emotionally. But scientifically, we're looking at is how fast, how we can make a landing. We got to reduce the speed of this object compared to the orbit. At a designed or designated place, we have to do the impact. Mathematically, extremely difficult job. So that is technologically challenging. Besides that, when the landing takes place, we'll be finding the altitude or using altimeter and try to find out whether any nearby, any traces of some gas near the Moon surface. There's an instrument for that. So these are exciting instruments. These are all not repeat instruments. They're all first of its kind. So it will be really exciting, and emotionally it will be the first object will be touching the Moon, and hopefully there will be a tricolor in that.
Developed by ISRO's Vikram Sarabhai Space Center at Thiruvananthapuram, MIP was initiated at the instance of former President Dr. APJ Abdul Kalam.
Which carries a small solid rocket on the top of the satellite, which is having the sensors to measure temperature, pressure and humidity of the Moon while it's approaching. While the satellite is orbiting the Moon, it will be released to go into the Moon's atmosphere by after firing, and by ballistic trajectory it will be spin stabilized. While descending down and crashing onto the Moon, it will give the parameters of temperature, humidity and pressure, which will be very valuable for this one.
Space Application Center Ahmedabad has developed 2 payloads. The Terrain Mapping Camera, TMC, a CCD camera for mapping the topography of the Moon. The TMC helps in better understanding of the lunar evolution process, as well as in identifying regions of scientific interest for detailed study. The Hyperspectral Imager is another CCD camera designed to obtain the spectroscopic data for mapping of the minerals on the lunar surface and also mineralogical composition of the Moon's interior. The height of the lunar surface features will be acquired by the Lunar Laser Ranging Instrument. Developed by ISRO's Laboratory for Electro-Optic Systems at Bangalore, the instrument helps in determining the global topographical field of the Moon, as well as in generating an improved model for the lunar gravity field. Another payload, the High-Energy X-ray Spectrometer, HEX, is designed to help explore the possibility of identifying polar regions covered by thick water ice deposits. HEX will also identify regions of high uranium and thorium concentrations. It is jointly developed by Physical Research Laboratory at Ahmedabad and ISRO Satellite Center at Bangalore. The Chandrayaan-1 Imaging X-ray Spectrometer is a European Space Agency payload, developed jointly by Rutherford Appleton Laboratory of Britain and ISRO Satellite Center, Bangalore. It intends to carry out high-quality mapping of the Moon using X-ray fluorescence technique for measuring elemental abundance of magnesium, aluminium, silicon, iron and titanium distributed over the surface of the Moon. The smart near-infrared spectrometer is another payload developed by Max Planck Institute of Germany to study the lunar surface, to explore the mineral resources, the formation of its surface features, the way different layers of the moon's crust lie over one another, and the way materials are altered in space. The sub-kilo electron-volt atom reflecting analyzer is built jointly by the Swedish Institute of Space Physics and Space Physics Laboratory of Vikram Sarabhai Space Center, Thiruvananthapuram. It will study the surface composition of the moon, the way in which the moon's surface reacts with solar wind, as to how surface materials on the surface of the moon change, and the magnetic anomalies associated with the surface of the moon. The Bulgarian Academy of Sciences has developed a payload radiation dose monitor to qualitatively and quantitatively characterize the radiation environment in a region of space nearby the moon. The mini-synthetic aperture radar payload is intended for the important task of detecting water ice in the permanently shadowed regions of the lunar poles up to a depth of a few meters. It is one of the two scientific instruments of the United States for Chandrayaan-1. Johns Hopkins University's Applied Physics Laboratory and Naval Air Warfare Center, USA, together have developed the payload. The Moon Mineralogy Mapper, M3, is an imaging spectrometer that will assess and map lunar mineral resources at high spatial and spectral resolution to support planning for future targeted missions. Developed by the Brown University and Jet Propulsion Laboratory of the USA through NASA, M3 will help in characterizing and mapping lunar minerals in the context of the Moon's early geological evolution.
Chandrayaan is primarily an Indian mission. Our own rocket is going to send up the satellite, and also the instruments on board the satellite, primary instruments, have come from the Indian scientific community. But at the same time, we thought it is a good opportunity to have the international cooperation. We are carrying 2 instruments from USA and 3 instruments from Europe on board this rocket system for looking at the moon at close quarters. So we believe that it is a very good opportunity for the international community to work with the Indian scientists on such a exotic project.
The Polar Satellite Launch Vehicle PSLV C-11 will put Chandrayaan-1 spacecraft into orbit. Weighing 316 tons at liftoff, the vehicle uses 6 larger strap-on motors to achieve higher payload capability. PSLV is a 4-stage launch vehicle employing both solid and liquid propulsion stages.
PSLV is an operational vehicle today, and this is a very unique vehicle. We had 12 consecutive successful launches so far, and this is adding a feather in the cap. That's a kind of scenario, and the reliability of the vehicle is extremely good. When we inject the satellite in orbit within the specifications, it is less than 2 sigma. It's about a sigma and 2 sigma level. So this only tells us that we need very little propellant by the satellite for utilization to put it in the proper slot. So the vehicle is very robust vehicle. The design is very robust, and it is a vehicle which is used for different applications. For example, generally we started using this vehicle for low Earth orbit missions, for particularly imaging missions, remote sensing missions, sun synchronous polar orbit missions. After this experiment, we have launched Kalpana satellite, 1.2 tons Kalpana satellite in the GTO orbit, that is used in the telecommunication orbit. Now the PSLV C-11 will be used for Chandrayaan mission. It injects the satellite in such a way, the satellite using its propulsion from the intermediate orbit, it goes to the lunar intermediate orbit, and finally it gets into 100-kilometer circular orbit with respect to Moon.
The Chandrayaan-1 spacecraft will be launched from the second launch pad at Satish Dhawan Space Center, Sriharikota, by PSLV into a highly elliptical transfer orbit around the Earth. The rocket separates from the spacecraft after reaching the geostationary orbit. The spacecraft reaches the lunar orbit and the Moon Impact Probe detaches from the spacecraft to land on the lunar surface. Following this, cameras and other scientific instruments are turned on and the 2-year probe begins. The ground facilities of Chandrayaan-1 perform the highly important task of receiving the microwaves containing the health information of the spacecraft and the scientific information. For this, ISRO has set up DSM-32, a 32-meter deep space network antenna at Bayalalu village near Bangalore. The station is capable of performing telemetry, tracking and command operations in S-band and science data reception in X-band.
Immediately after separation from the launch vehicle, we have requested the support from the ground station at Hawaii, United States, USN, the United Spacecraft Network. Those people will be able to support us for Chandrayaan mission from Hawaii ground station. Then the Deep Space ground station of NASA at Goldstone will be able to further enhance it. And we have also talked to our colleagues in Brazilian Space Agency, who will provide us tracking support from the Brazilian ground stations at Coiba and Alcantara. With that, our own Indian network ground stations are quite a comprehensive network is there. We have got a Russian ground station in Bears Lake that will be able to provide support for Chandrayaan tracking. And we have our ground station in Mauritius, Trivandrum, Port Blair, Brunei and Biak, and Bangalore, of course, is the primary ground station. All these things put together, along with Lucknow ground station of ISTRAC, we'll be able to really make it almost continuous tracking possible through a worldwide network. This will be required more in terms of the orbit raising phase and also to reach Moon. Once we reach Moon, Bangalore ground station will be the major one in the Eastern Hemisphere. There is another ground station which is part of the American system that's under the Applied Physics Laboratory of the Johns Hopkins University. An 18-meter antenna is there, which is similar to whatever 18-meter which you have seen here. That will help us in cutting down the time of science data acquisition. We have got a capability for about 12 hours tracking from Bangalore. Another 12 hours will be covered by the Western Hemisphere ground station. So whatever we have called 2 years of mission life for Chandrayaan to do the science investigations can be cut down to about 18 months with these 2 ground stations. They will work in tandem, half a day for Bangalore, half a day for America. With that, we'll be able to cover the data acquisition.
The Antenna and Satcom division of the public sector Electronic Corporation of India at Hyderabad has designed, developed and manufactured this antenna for ISRO. Over 38 industries and construction companies came together in a national expedition to set up the antenna. The cost is over 100 crores of rupees out of the total 386 crores project cost of Chandrayaan. ISRO Satellite Center ISAC and Bhabha Atomic Research Center BARC have designed and developed radio frequency system and antenna controlled servo system for Chandrayaan-1. The Indian Deep Space Network is ISRO's initiative to build the ground infrastructure for Chandrayaan-1 mission. It will take care of Chandrayaan-2 and beyond and collaborate with other international space agencies around the globe. The IDSN will provide the two-way radio communication link between spacecraft and the Earth. The station enables the reception of telemetry signals from the spacecraft and also transmission of commands to the spacecraft to perform various functions. The station is also capable of receiving the science data from the instruments, which will be operated from the Spacecraft Control Center. During the International Astronautical Convention 2007 held at Hyderabad, the Chandrayaan project was presented to the international delegates. The efforts of ISRO in cutting down costs on such missions were widely appreciated by the global community. India has taken the lead in low-cost access to space. The focus would include an emphasis upon environment monitoring and sharing data with international partners. The scientists are of the view that for all future missions, there must be international collaboration so that the benefits can be used by a global community. Chandrayaan-1 is expected to realize the mission goal of harnessing the science payloads, lunar craft, and the launch vehicle with suitable ground support systems, including Deep Space Network Station.
How to run our programs in a cost-effective manner without cutting corners. Of course, the Indian technology development, it is by and large done by the government-funded organizations, and that development charges are not loaded onto the actual mission costs. That's one aspect. The second, I think, by and large, our industrial costs are low, but it is not sufficiently low to have a very strong competition with others. I will give some examples. Though our manoeuvre rates are small, low, I mean at least 50% compared to the outside, but the productivity is not in par with many of the developed countries, even our neighbor Chinese, if we take it. So if you multiply these two factors, we are at somewhere about 60 to 70% of the international cost we can deliver the system.
During her visit to Hyderabad IAC 2007, astronaut Sunitha Williams recalled the experience of space travel as a thrilling experience. Cutting across all narrow boundaries, any space mission has something to offer to humanity.
Personally, I think if we're going to leave low Earth orbit and go to another planet, I think we'd want to go there as people from Earth rather than a specific country. Now, the economics of getting all the countries together and their assets, that's another question that we need to work on. And I think all of us up here would agree that I think working on a peaceful project like the International Space Station is absolutely the right way to go. And just remember, when you really look at the planet, it's borderless. It's absolutely borderless. There are no borders. That's only what we draw on a piece of paper, on a map, or on a globe. And the second part that translates to is what you perceive are your limitations and your borders in your mind about what you can do. You can do everything and anything to help us save our planet and figure out how to join the space agency. Doesn't matter if you're a man or a woman, a boy or a girl. Some of those perceptions might be yours, some might be the people around you, but it's all just a perception.